Assalamualaikum and good evening. My name is Ameerah, and together with me I have Mama Haziq and also Misha Mahirah. Today we'll be presenting about a study on the trend of early childhood death in Malaysia using mathematical modeling approach. Moving on, in this study, we focus on analyzing the pattern of early childhood death, specifically for the children under the age of 5 in Malaysia. To do this, we use data set from the Department of Statistics Malaysia, which are available through their open data portal. The data is titled Annual Early Childhood Death, which provides data from the year 2000 to 2023. To assess how well our model fit the actual data, we calculated the error vector, which measures the difference between the observed values and the values predicted by the model. We also computed the magnitude of error vector to quantify the total error. All calculation and visualization were done using Maple software. With that overview in place, let's now take a closer look at the data and walk through the process of curve fitting and error analysis.
So by using the previous matrix that we made, we can finally make the matrix M by combining matrix ATA and ATB. Then we perform the RREF method of to matrix M, and then we will find the equation of the best fit curve. So we'll be using the first, and then we use the equation of the best fit curve to make the plot of this data set by using B. Then we display the both D and B graph in the same time to find to look at the best fit curve and the data point of the data.
So next, we are going to discuss about best quadratic curve by using manual calculation. Firstly, for manual calculation, we need to find the equation for quadratic curve, which is y is equal to a plus bx plus cx squared. And then using substitution, we've come out with least square solution. By using ERO, we know that least square solution will come out with inconsistent answer. Therefore, we proceed with normal system, which is A transpose AX is equal to A transpose B. As you can see here, this is the result for normal system. Next, after solving the normal system, we need to find the value of X. In order to find the value, these are two important formulas that we have to know. And then we have to find the determinant, cofactor, and the adjugate of A. After we have calculated these three values, we need to substitute it back into the second formula that we have shown above. For the last step to find the value of x, we need to substitute it into the equation for quadratic curve.
So lastly, to find the magnitude of error of this equation, we will first use the coding that we shown, the make underscore r equals to norm upper bracket matrix r comma two close bracket, and here we see the result of the magnitude error.
Now I am going to show you the manual calculation of error vector. As we all know, the formula of error vector is the difference between y and the product of mv. We have obtained all the values of y, m, and also v is just the method of substituting and calculating. Now that we have the formula for the error vector, which is e equals to y minus mv, our next step is to find the values of mv. We use the quadratic model in vector form and compute mv using this formula. shown here on the right. It includes the constant term, the linear term, and also the squared linear term. Each value of MV is calculated by plugging in the respective xi values from 1 to 10. As a result, we obtain a column vector containing 10 values of MV, which represent the predicted number of early childhood death based on our fitted quadratic model. This completes the second step in our process. Next, we'll compare these predicted values with the actual data to compute the error vector. Now that we have the predicted values from our quadratic model, which we call MV, we can proceed to the next step, which is to find the error vector. Since we are given the value of y, by subtracting each predicted value from its corresponding actual value, we obtain a vector of errors or residuals. These values show how far off our model is from the actual data. This step is also crucial for understanding the accuracy of our model, and it also sets up to calculate the overall magnitude of error. Now let's evaluate the overall fit for our model by calculating the magnitude of error. The formula is the square root of the sum of squares of all the individual errors values. Mathematically, it looks like this. After substituting in all the error values and performing the calculation, we get a total error magnitude of approximately 794.15. This result tells us that our model is not a perfect fit since the error values are not zero. However, depending on the context, this level of error might still be acceptable for identifying the general trends.